In this lesson, we want to talk about a new data type. It's an integer data type, like integer and long, but it has special uses. It's used for symbols. Let me just show you what I'm talking about here. Down here, let's paste in some code. Okay, so here's the character data type. It says these variables, A, B, C, and D, can hold numbers from 0 to 255. Typically, they're used for keyboard characters, as set out in the ASCII table. That's a computing standard. Okay? So if I go and look at the ASCII table, you can see that all the characters on the keyboard are associated with numbers. Okay? So when you want the letter A, you're actually referring to the number 65 of the ASCII table. So the next question is, so how do I tell it I want the letter A or 65 in the ASCII table? Well, that's fairly straightforward. I'm going to show you some other code. Go back to the program, and down here I'm going to put that code in. Okay. Here I'm initializing it. There's two ways to initialize the variables we're talking about. A single quote, not a double quote. That's very important. Tells them that the letter A, that the variable A holds the letter A. 97 actually is the letter A if we go back to this table. Here's 97, it is A. So that's the same way of talking about the same thing. It's easier for us to remember the symbols than the ASCII numbers for it. And then you have the number 5, which is ASCII 53. Let's check that. It's not on this window. Go back. Look at this window. Here's 53. Yes, it's the numeral 5. Now it's very important that you understand that the symbols are not numbers, right? So the symbol 5 is not the number 5. And if you wanted something like the statement, if C equivalent to 5, the answer to that would be no, because C is actually value 53. Okay? On the other hand, you could use this setup. This would be true. C does equal the symbol 5, or you could use 53. But you're more likely to use this because you can read it more simply. Okay, let's go back here. Let's compile this. Okay, it worked. Let's call up this screen. I didn't reset it from where I tested this before. Okay, here we are. It's waiting for enter. Now it prints it out, right? So the variable A is the letter A. Okay, 97, 97, 5 is 53. Okay, so in this code, %C, this format specifier actually tells the C compiler to use the symbol from the ASCII table. Okay. Now there's some special ASCII code that's worth looking at as well. Let's go back to this table right here. There's two keys on your board that you use an awful lot. One is the escape key. Turns out that the escape key is labeled as number 27. Okay? And as well, there is the carriage return or enter key. That's 13. If you want to talk about those guys in code, you would need a few lines that look like this. Okay, so instead of this, you have this. So A is 27, it's the 27th ASCII entry. If you want to use the quotes, because there's no escape symbol, it's \27 inside of quotes. Same way the carriage return or enter key. It's 13 or \13. Now, let me actually make that one D. Let's try printing, compiling this and seeing what we get. Right, so we're going to compile this on the chip. We're going to look here. We hit enter, and you see none of these symbols actually showed up. That's because they're non-printing characters. Right? When you hit enter, no symbol appears on your screen. When you hit escape, nothing appears on your screen. So it couldn't print anything. So in general, you don't want to, in your printouts, print things that are non-printable characters. They don't print. Messes up all your text formatting too.